As you can see in this particular electrical circuit, the 6 ohm resistor and the 3 ohm resistor are both connected between the same nodes. It means that they have a parallel connection. Similarly, this particular 3 ohm resistor and 6 ohm resistor are also connected in parallel. So we can say that the equivalent resistance will be 3 into 6 over 3 plus 6. Okay, so that is equal to your 2 ohms. Similarly, they are also connected in parallel. So we can say that the equivalent resistance of these two resistors will be your 2 ohms. Okay, so this particular electrical circuit can be redrawn as, so 2 and 2 ohm resistor are both connected in series with each other and their combination is connected in parallel with the 12 ohm resistor. It means that the equivalent resistance will be equal to 2 plus 2 in parallel with your 12. That will be equal to 4 into 12 over 16. So that is coming out to be your 3 ohms. Okay. So this particular circuit, we can simplify it as, this will be the simplified version of this particular electrical circuit. Okay. So as you can see, the 3 ohm and 3 ohm resistors are both connected in series. Okay. And their combination is connected with in parallel with the 2 ohm resistor. It means that the equivalent combination or the R equivalent will be your 2 in parallel with 3 plus 3, which is equal to your 6 into 2 over 2 plus 6, which is 8, which is equal to 2, 3, 1.5 ohms. Okay. So the R equivalent circuit or the total equivalent resistance seen by the voltage source will be the series combination of 1.5 plus 1, which is equal to 2.5 ohms. So according to Ohm's law, the current flowing from the voltage source will be equal to, I will be equal to V by R, which will be equal to your 15 over 2.5 ohms, which will be equal to, like after simplifying it, we are getting 6 amperes. Okay. So in order to find the value of current I from 3 ohm resistance, we need to first find the value of the current flowing from 2 ohm resistance. Okay, so we need to find this current. Okay, so using the current division principle, we can say that I will be equal to, so I from 2 ohm resistor, so I of 2 ohm resistor will be equal to, like the total current, which is 6 over into 6 upon 6 plus the total resistance, which is 6 plus 2. Okay, so 6 6 are 36, that will be equal to your 8. So it will be equal to 4.5 amperes. Okay, so the current flowing from 2 ohm resistor is your 4.5 amperes. Okay, similarly, this particular 2 ohm resistor is the parallel combination of 3 and 6 ohm resistor. So in order, so this particular 2 ohm resistor is the parallel combination of 3 and 6 ohm resistors. So in order to find the value of the current from 3 ohm resistor, we will again apply the current division principle. So I of 3 ohm will be equal to the total current, which is 4.5 into 6 over 3 plus 6, which is 9. So it will be equal to 3. So 3 2s are 3s are it will be equal to 3 amperes. Okay, so I of 3 ohms, so the total current, okay, so the current flowing from this particular 3 ohm resistor will be equal to 3 amperes. Okay, I hope it is clear how we are approaching the problem. Okay, so next let's start with the second problem. Okay, so in the question we need to find the value of this particular resistor R. Okay, and it is already given that the power that has been absorbed by this particular 16 ohm resistor is your 160 kilowatts. Okay, so in this particular loop, okay, in this particular loop we can directly apply Ohm's law and we can say that the value of Vx will be equal to 20 into the current flowing in this particular loop, which is 20 amperes, into the resistance R. Okay, so this is your first equation. Okay, so in this particular loop also, it is already given that the power absorbed by this particular 16 ohm resistor is, so P is equal to your what, V square by R. Okay, So P will be equal to V square, which is 10 times of Vx. So V will be equal to 10 Vx. Vx is already given to be 20 into R whole square, okay, divided by your resistance, which is 16 ohms, okay. So P will be equal to, it means that, like, so P will be equal to 200 square R square over 16, okay. So in the question, it is already given, like, the P is equal to 160 kilowatt. So on substituting the value of P in this particular equation, we can say that 160 into 1000 is equal to 200 square. So into 16 into R square is equal to this. So it will be equal to 4 R square, 16, 16, 256, okay. So 464. So R will be equal to, from this particular, we can say that the R is equal to, R square is equal to 64. So R is equal to, this means R is equal to 8 ohms, okay. So I hope it is clear how we are approaching this particular problem. Okay, so that's all for today, guys. I will see you in the next tutorial. Thank you.